Hello everyone, I hope you all are doing well. So here I came up with Fusion 360 assembly and drafting. So I'll cover the basics of assembly workbench, bottom up assembly approach, and the drafting, assembly drafting, as well as the basics of part level drafting. Okay, so you can create the project and you can just add the folders inside it, and you can save the components inside that folder. So let's say I'm considering engine assembly here. So for our convenience, what I did is I had already created the component and I had saved them into the folder. Now I have the components inside this Fusion 360 assembly, which I had already stored the components to just showcase the bottom-up assembly approach. These are the components. Okay. So before dragging and dropping them and starting the assembly, I would like to use the origin, and from this front plane I'd like to create a sketch which will act as a reference. So this is a triangle, so I'll take this as 65. Okay, and now I'll refer these corner points as my reference. So first thing is this crankshaft. You could see the name engine assembly. Once I drag and drop it, the engine assembly part will change to assembly. Okay, now you can use these triads to orient your model however you want, and just align it where you want, and then simply click on green check, the best way to orient it. Once that is done, you can use this joint, or else the shortcut is J. So it will help you to snap the location. So I'm gonna select the midpoint, and this it's gonna have the rigid, but I don't want that. From the motion tab you can change it to revolute, so it will revolve around the z-axis. I want that, and the coincident will be automatically snapped. Remember that. So in SolidWorks we need to define multiple mates. So here it is one, so in one shot it will take. Now I need this gear. I'll drag and drop it. Okay, once you do that, you can just align it, as I said, by using the triad. You can do it, and now activate J, this face and this face. I need the same, but this time I don't want the revolute, I need the rigid, because anyway I'm having the shaft as a revolutionary, no? So this gear should have the locking mate for that, so better make it rigid. Okay, now this gear 2, I'll add it again, I'll orient it. So now this gear, I'll just select this edge and this point, and now I don't want the rigid here because it should rotate. I'll use the revolute. Fine. Yep, so this much is done. Now I need the linkages. So we have the advanced mates. For that I'll showcase it. Before that I would like to add this camshaft here, so this will be helpful to just add the walls. Okay, so again J, these two, snap it, automatically it will take, but here I need the rigid. Again I'll just snap it. Now this has the linkage with the gear. Now I'd like to add the motion link to have this capture will help you to just capture the preview. Okay, so these two mates I want to assign the gear mate, so you can just activate the reverse. So it is 360. I would like to change the gear ratio. I'll take it to, it's too much, 1.5. yeah, so this will work fine. So even you can change it to with respect to the angle 360, and this is half of it, so 180. So this will also affect the same. This is kind of gear ratio. Okay, so this gear ratio will be activated, so now you can use it whenever you want. Now I do need some of the references to add other components. So what I'll do is I'll refer the origin, so I'll just show all the origin references. This plane I need, right click on it and create sketch. So here to place other components I need again the reference axis and the reference point. So I'd like to add this sketch, as you could see, and the dimension I'll specify it. So activate the dimension. D is the shortcut. I'll take this as 50 both, and this dimension as 15 and 15. Now this line should be exactly at the symmetry between these two edges. I'm using the shortcuts. Okay, and this point should be aligned with this, so just select these 2 points and use make vertical or horizontal. Okay, so this is fine. So the dimension I need it, so the vertical dimension I need to assign. So what I'll do is just use D shortcut and just select this line. This is 300, just for a reference. Okay, yeah, the first sketch is done. So I'd like to add one more, but I need a plane now. So plane should be on this particular shaft. So I'll use this offset plane. I'll select this plane. Instead of distance, I'll select the object. So this time I'll just select this point. So if I click on OK, I'll be having the plane on this. You could see, right click and create a sketch on it. So you can refer the other component origin and the reference planes, but as you are going to move them, they will be having degrees of freedom. They might change, so better create the reference planes. Okay, the same sketch I'm using it here. This is to add the inlet and outlet walls. So this is 200, and then I need to define this as 50. Okay, and this point and this point, snap it coincident. Done. So this is fully defined. Just finish the sketch. Now one more sketch I need, which should be exactly at the symmetry of this plane. So here what I can do is I'll create one more plane, offset. So reference is this plane, the object is this, and the reference is this point. So if I do that, I'll be having the plane exactly on that location. Could see. Now simply right click and create sketch. The same sketch, but this time to place the top shaft, I'm using it. Okay, so this I'll take it as 300 again. This is 40. Okay, and then yeah, this is vertical, and then I need to snap with this. I'll use the collinear. Yep, fully defined, green shine. Now I'm having the reference sketches to align them, so I'll add the components. Now this rod, I'll just simply drag and drop it, and this should be oriented according to the requirement, and then J shortcut for the joint, this face and this line. I don't want the rigid, I want the slider up and down. I'll activate this. Okay, I need a copy of this rod. Right click, copy, and again right click and paste, and just drag it out. This quick access tool will help you to do that. Just switch, select this again, automatically it will take the previous mate. Don't need to worry, these two are fine. So next component, I would like to add the sub-assembly this time, the wall sub-assembly. Just drag and drop it. Now simply orient it. Yep, so again, before doing it, right click on it and create this rigid group, because this is a sub-assembly. If you just select a component, only the component will be mated, remember that. So like this, if you just hit on green check, it will take entire assembly. I need a copy of this. Again right click and paste, and just capture the location to have the same preview window, and then again make rigid group, J shortcut, this and this. Yes, this sliding along Z. Yep, so we have added the components which and all required. So now again I need the shaft. So this shaft, I'll place it here, rotate it. Oh yep, so this should be exactly at the center. So if you want to snap the center, you need to zoom in and just hold the shift and try to hover, get the center. The same thing here as well. Okay, I want it to be rigid, because that shouldn't rotate as well. If you want, you can have it rotation, but to assign all the mates I want it to be widget. So this rock arm, I'll just drag and drop it again. So just place it wherever you want, orient it properly using this triad. Click OK, J shortcut the joint, and then this edge reference, it will snap this XYZ coordinates again here on this. So automatically it will take the coincident and the concentric, and you just need to change it to revolution, that is concentric here. Quite easy to use interface here. Need a copy of this, right click and copy, right click and paste, drag it out, click OK, and then same thing, this edge and this edge. By default it will take the previous mate, don't worry. Okay, this is done. So next thing is only few components remaining. One is piston. Would like to just hide these all the sketches, I don't want them now. Just scroll up, you have this connecting rod and the connecting rod cover, so and piston height. So I'd add this connecting rod, and now I'll place it here. Okay, now I would like to have the center point snapped, so J shortcut, joint, hover. Yep, so again here on this, just check this is not the center, this one. Okay, we have the rotation, revolution along Z, this is fine. And then now I'd like to add this connecting rod cover here. Very important thing, in SolidWorks we're gonna define the coincident mate, parallel mates and all here. Now to assign this, could see, I'll click OK. Now this face, hold the shift to just select this center snap. Yep. Now here this face, it has the rotation now. Okay, it doesn't have the coincident between the top connecting rod. To assign that, again I'll activate the J joint, this face and this face. So this will take the revolution along this, so it will be automatically taken coincident for that, remember. So multiple mates can be assigned, but it should need some intelligence to apply them, so sometimes it is quite difficult. Yep, the final component is the piston head. Simply drag and drop it here. Again it is a bit complicated to assemble it, just rotate it according to your requirement. Now here first thing is I'll assign the width weight kind of thing, so between two selected faces, and automatically it will snap the origin. Just select that, and same thing component 2, I'll switch to the between faces, this face and this face. Once you select these two faces, automatically will help you to select the center point. Just snap it. I don't want the sliding, I want the rotation. So you can switch the motion, just change it to revolute, then click OK. So now I need the sliding as well, because this piston should orient to this, right? Yep, so it is 90° automatically, don't need to worry, just click OK. Now this is aligned with the axis and it has the rotation as well. I'll hide all the sketches and the joints. Yep, so this is how you can just deal with the assemblies. Okay, it is very important, like how to use the user interface and the tools very efficiently. Now so I'll simply hide everything, and now I'll position everything properly. Now I'd like to take the left view, these dots exactly here, so that I can assign the contact sets, and I'd like to animate it according to the requirement. So this is fine here. Front view, just orient these arms, so I'd like to have this distance, this is fine, and here as well, these are the wall sub assemblies, so even I'll orient it like this, so the placement should be fine. Yeah, so now once the placement is fine, so you can activate the contact sets using the assembly drop down. So I need the joints now. Before that, let me just check these. So you could see this is not this one. Yeah, slider 12. So just activate it and just change the value 18.45, the position exactly. The same thing for this, so it is the rest position. Okay, so wherever you make the changes, it should come and sit there only, because that is the rest position. So here as well, just check the dimension minus 110.381. So I'd like to add the same thing for this slider. Okay, so and again this one, just check the value, it is minus 186.74. just add the same here. So resting position, why I'm adding this is, if you move the component, it should come and sit to the original location once you remove that movement. Okay, let me just showcase the same here. Let me go with the contact sets. This is enabled now. I'll define the new contact sets. Once I enable it, then only you can able to define it. These two should have the contact set. Again, these two, it will be like 𝐂𝐀𝐄 and SolidWorks. Again here, this is a contact mate. Again for these two, we have the tangent mate in SolidWorks for this, but here we don't have it. We have the contact sets here for all. It's easy as well to define only single mate everywhere, but it has some disadvantages. I don't want to disclose, let it be now. So if you try to move this according to the movement, you could see the valve is even moving, even the rod is moving. According to that, you have the mechanism, right? So if you want to generate this one by using the motion study, what you can do is go to this motion study here, just drag and drop the meat, this meat, the revolution, it has -2 degrees. I'll simply go to this point, I'll change it to 360 degree at 100 step. So now this particular meat 0 to 360 degree, it will rotate, and you can just animate this according to that, and you can simply play it. Due to some glitches, it has some glitches, so you won't get the proper animation for this due to that 𝐂𝐀𝐄. For others, it will create the appropriate animation. You don't need to worry about it. Yep, so that is done. Next thing is to create the drafting, assembly drafting. So if you just use this option here, we have the standard A3. I'm using ISO. So once you have it, automatically you're gonna have the model tab. So from here, drawing view, you can select I need the isometric view. Like change the scale to 1:2. I'll change it to shaded view. Fine. So now next thing, I need the projected views. The front plane is fine, sorry, front view. I do need the projected view for this. I'll click OK. I'll switch to the projected view. Just select this drawing view and just simply drag and drop it. So you could see this is the isometric view, this is the top view. Front angle first angle projection I'm using. Okay, so now once you're done with this, you can even add the dimensions manually. I would like to add the table automatic method. Okay, once you define it, automatically balloons will be created. According to that, table will be ready. Double click on this will help you to just change the things inside the bill of material. You can remove the description if you want. If you want to align it properly, let's say I want the quantity should be at the third row, you can just adjust it. Third column actually, item number, if you want to skip, if you can do it. Okay, like this you can customize your BOM table. So we have the up title direction, table direction, and we have the structure to all level, and we have the first level as well. So this will help you to add the sub assemblies as well. Okay, and these, once you create the ballooning automatically, and you can able to rearrange it, simply double click on it and drag and drop it wherever you want. Okay, so this is quite handy to just deal with this ballooning as well. If you have the manual ballooning options, okay, you can even use the datum things, you can use the manual dimensions, geometric symbols and all. Okay, modify tools, create tools and all, everything you can do here. For using the annotation, we can add the note. Let's say this is the front view, and you can even change the font color and the type, everything here. So before that, you need to select the entire text and just change the color. If you want to change the font, you can do it. Okay, so here Arial black, bold. Same thing, you can assign the views for all the other views. Okay, can't copy it, you can simply repeat the text, drag a box, and do the same thing for others. Okay, yep. So this is about assembly drafting. If you want to just change the template, you can simply double click on the drawing template and you can make the changes. Okay, finish properties, and now we will see the part drafting as well. Just basics. I'm not going to go with the manufacturing approach. You can use this component A3 format, ISO standard. I'd like to add the front view is here. I'll change it to isometric view from the orientation drop down. Okay, now double click on it to change the shaded mode. Okay, and then I need the other views with respect to the front angle, first angle projection. I'll take the front view, I'll place it here, click OK. Projected views, you can use it. Before that, I would like to have it the view edges only. This is not this unprojected view, this the top view, the side view. Yep, so escape. You can just align them, you can move your views according to the requirement. And then I would like to add the section view. I'll select it, I'll draw a line like this exactly at the center, green check, drag it out. You have the different options here. In the depth, we have the slice only. If you want to take full, you can have it. Okay, if you want to use the distance, you can even use it. Threaded edges, we have the tangent edges. If you want to deactivate, you can do it. And then we have the styles as well. Okay, hatching and all automated here, we can't customize it. If you want, you can just deal with the drafting tools. Next thing, the detail view, you can simply drag it and the location where you want it. If you want to change the area of it, you can even do it later. So these are the few options here available. The scaling is by default multiplied by that. You can drag it out to increase the detail view size. Okay, so in inventor, we have the what it is that retrieve dimensions. If you have created the model using the inventor, you can even retrieve the dimensions feature by feature, but in Fusion 360 that tool is not available, I believe. In future they might add it. If it is there, I need to research about it, I believe. Okay, using the manual dimension, you can define the dimensions here. So with respect to the ISO standard, it's gonna take the orientations and the placements. Okay, so like this, you can just specify the dimensions, GDT symbols. If you want, you can even specify that angles and all, everything you can add it. This is quite simple as we use invent tool. So his interface is the same, but it is quite advanced. Yep, so like this you can able to deal with this particular part level drafting. Okay, you can just place your views according to the requirement. Yep, so that's all about this session. So in this session we had gone through Fusion 360 assembly workbench, and after that the assembly drafting, and then part drafting we had seen. Yep, so that's all about this session. Thank you guys, stay tuned, bye everyone.